Okay, so for this worksheet, the first couple problems are purely review from the last worksheet, so I'm not going to talk about those. Questions on the back of the worksheet, they have things that say like compute the antiderivatives, find an antiderivative such that, blah, 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 and they have compute the indefinite, evaluate the following. And so what do these things mean? So I want to give you a couple of each as an example so you know that it's all finding antiderivatives. But exactly how do you gift wrap your solution? Okay, so here's 4 different types of questions that are all based around taking the antiderivative of t squared. So the point is, do you just understand what the question wants you to do beyond the obvious, well, I'll take the antiderivative. So in the first case, compute an antiderivative for this guy. Well, it's going to be t cubed, and you have to multiply by 1/3 so that you don't have leftover bits. Okay, you're going to probably want a plus c, but if it just says compute some antiderivative, then I guess it's not that big of a deal if you forget it. It depends on the wording of the question. Apparently my computer decided to jiggle on me. Okay. All right. Now, you probably want to give it a name. F is good. Capital F is good. All right. Compute the antiderivative so that f of 0 is 0. Well, in this case, you're specifically being told that you have information so that you can figure out what c has to be. And in this case, for this to work, c has to be 0. So it doesn't look like you're adding anything. It looks like you're just getting rid of the c, but they could have said f of 0 is 1 or f of 1 is 1 or something like that. You could fit some other condition, but no matter what, you use that c to fill in that gap and make the requested statement, the requested condition will be true. Okay, what if you just want to compute the indefinite integral? Well, then you just do this same thing again with the plus c. And then to evaluate, you still do 1/3 t cubed, but you don't need the plus c anymore, and you want the upper and lower limit of this. So you want 1/3 of 3 cubed minus the lower end, 1/3 of 1 cubed, which is just 1/3. So this is just, you can factor out the 1/3, of course. 9 minus 1, 27 minus 1 is 26. Okay? So that's the difference in the instructions. In all cases, you still just take the antiderivative. It's just your finishing touches are different depending on the instructions. Let's do a few examples. Okay, here's some good ones. All right, so let's say I want an antiderivative for 1/t to the 5th, which is t to the minus 5th. So we're looking for a capital F such that when I take the derivative, when I subtract 1, I get a -5. So this must actually already be a -4, right? But the problem is then if I were to take the derivative of that, I get a -4 out front. So I must divide by a -4, and then there's a constant that may or may not be there, but it's not required in this specific instance. When I ask for the indefinite integral, then I mean that you have to add the plus c. If I say compute an antiderivative, it's implied that you can leave it off. It doesn't technically have to be there. Okay, what if we want to do the same thing for this function? Well, you're going to get natural log of x plus 2 plus c, and this time you really do have to use the c, because natural log of 2 plus c has to equal 0, so it turns out c has to equal negative natural log of 2. So your final answer is going to be natural log of x plus 2 minus natural log of 2. Okay? I'm sorry, I need an F. There we go. Capital F. Sorry about that. Yeah. What about compute the indefinite integral? Okay, so this question you may be tempted, especially if you took calculus before, to bring out the heavy artillery. But remember, this is an introductory situation here. People don't know how to use certain rules that you may be thinking of, and this is meant to be done in the simplest possible way, and then I will let you go from here. But I'll just do the first step for you so you know that that's the strategy. You're not expected to use fancy rules here. Okay, next type of question I want to do just for fun. What function, when you take its derivative, gives you sine of x? Well, it's kind of sine and cosine go back and forth. But the derivative of sine is cosine. Derivative of cosine is negative sine. So that means I have to put a minus sign in. So if I take the derivative, I get back to sine. What a pain. Okay? But not to worry. So what you're going to do is you're going to say minus cosine of 2 pi. And since there's already a minus, put a plus here because you're going to distribute that negative. Cosine of 0 is 1. Cosine of 2 pi is also 1, and this thing wipes out. Very cool. Anyway, I just thought you'd have fun with that one. Okay, and that's all the hints I'm giving you. You should be a master at this stuff by now. Okay, see you in class.